In this video, let us solve this problem to better understand how we can use mole concept and stoichiometric coefficients. They are these numbers that are before these molecules. How we can use mole concept and these numbers to be able to find the amount of a reactant that has been used up or the amount of a product that has been produced in a reaction. Let us see. In the reaction below, 15 grams of ethane is used. So what we know here is that 15 grams of ethane is being used in this reaction. What we want to find is the amount of oxygen that is used and the amount of carbon dioxide that is produced. Okay, these numbers are telling me that if we have 2 molecules of ethane and 7 molecules of oxygen, then they can react to produce 6 molecules of water and 4 molecules of carbon dioxide. That means that the ratio of the number of molecules of ethane and oxygen will always be 2:7. And we also know that the number of moles is directly proportional to the number of molecules. So we can also say that the number of moles should be in the ratio of 2:7 to be able to complete this reaction. Okay, this gives me a hint. I know the mass and I also know that the number of moles should be in a ratio of 2:7. This means if I can convert this mass into number of moles of ethane, then we will know how many ethane moles we have, and based on this, to maintain this ratio, we can then find how many moles of oxygen must have been used up, because this ratio of 2:7 should be maintained. And once we find the number of moles for oxygen, we can then find the mass for oxygen, which is what we need. We want to find the amount of oxygen used up. We want to find the mass of oxygen that was used up. So let's do this. We want to go from mass of ethane to number of moles of ethane. Then using the stoichiometric coefficients, we want to go to the number of moles of oxygen and then find the mass of oxygen. Before I do this, why don't you try it on your own? Pause this video and give it a shot. I hope you have tried it. We know that 1 mole of ethane will have molar mass of twice the molar mass of a carbon atom plus 6 times the molar mass of hydrogen atom, because we have 2 carbon atoms and 6 hydrogen atoms in a ethane molecule. For a carbon atom, we have a molar mass of 12, so this is 2 into 12, and for hydrogen it's 1, so we get 12 plus 6, that is 30 grams. So 30 grams in 1 mole of ethane. So if we divide 15 by 30, we'll have half, so there are half moles of ethane here. We now know the number of moles of ethane. So we can see that 2 moles react with 7 moles of oxygen. This means that 1 mole of ethane would react with 7 by 2 moles of oxygen. And so half a mole of ethane will react with 7 by 4 moles of oxygen. That makes sense. So this will be 7 by 4. We must have used 7 by 4 moles of oxygen. And to find the amount now, all that we need to do is convert this number of moles into mass. So what is the mass of 7 by 4 moles of oxygen? That is 7 by 4 times the molar mass of oxygen, which is 32, because there are 2 atoms. So 16 plus 16, 32. This gives me 7 into 8, that is 56 grams. And that is our answer for the amount of oxygen. 56 grams of oxygen must have been used. Now using the same logic, let's see if you can find the amount of carbon dioxide produced. Pause this video and give this a shot now. I hope you have tried it. So we already know how many moles of ethane we have used, and we know that for every 2 moles of ethane, 4 moles of carbon dioxide are produced. So double of ethane. So the ratio should be 2:4, that is 1:2. This means if we are using only half a mole of ethane, that means that we must have produced half times 2, that is double of half, 1 mole of carbon dioxide. And what is the weight of 1 mole of carbon dioxide? 1 mole of carbon dioxide will have a mass of 12 for 1 atom of carbon plus 2 times 16 for 2 atoms of oxygen. This is 12 plus 32, that is 44. So 44 grams of carbon dioxide must have been produced in this reaction. So in this way, by converting mass into number of moles and using the ratio of stoichiometric coefficients, you can find the amount of product used or the amount of reactant produced.